Welcome to EDU World Space.
This question asks us to write the names for 4 different complexes using standard nomenclature rules. So the standard rules for writing out the names for these complexes, there's 6 main rules. The first is that you always write the cation before the anion. The second is that within the complex, it goes ligand before the metal, and the metals are always in alphabetical order. Third is that anionic ligands end in O, but neutral ligands stay the same. Fourth rule is that for the case of multiple of the same ligand, use Greek prefixes. The fifth rule is that anion complexes end in ATE, 8. And the sixth rule is that the oxidation number for the metal is given in parentheses. So given those 6 rules, we'll start with A, where we start with the cation part of this complex, which is the metal and ligands. The anion is this chloride ion. So starting with the cation and then starting with the ligands within the cation, we have this NH3, which is an amine, and there's 4 of them. And then we have this chlorine, which is a chloro. So for these names, the amine and then chloro, our amine is going to come first. So, and there are 4 of them. So with the Greek prefix, we're going to have tetra amine, di chloro, and that's all one word. There's no spaces in there. And then the metal, so RH is rhodium. And we have to include the oxidation number for this metal. And so the oxidation number for this metal, you have 2 chlorines, which are -1, so that's a -2 charge total, plus this chlorine is a -3 charge total. Our NH3 does not contribute a charge, so we know because it's a neutral compound, the RH needs to be a 3. And then we include our anion, which is the chloride. And there is a space between the cation and the anion. So there's a space there, and then chloride. Moving on to part B, our anion is potassium. So we have potassium, and then a space, and then our complex, where we have our metal Ti and our Cl or chlorine, chloride ions. There are 6 of them, so it's going to be hexachloro, and then titanium. But because it's part of our anion, it's going to be and let's erase that real quick. Too much of a space between there. T-A-N-8 A-T-E. So we need to end our anion complex is an 8, and we need to know the oxidation number for this metal. Chlorine is a -1. There's 6 of them. That's a -6. Potassium is a +1. There's 2 of them. It's +2. The molecule is neutral, and so Ti needs to be 4. So IV Roman numerals. Part C, we're going to go to the next page, is this complex here with 2 ligands. So we've got the O and the Cl4. The Cl4, the chloro, is going to come before in alphabetical order to the oxo. So we're going to have tetrachloro, and then the O, the name for the O is an oxo, OXO. Our metal is B, and then our oxidation number for this molecule, we have the -4, and so we know that this ion needs to be, or we have the -4 here, -2 here, we know that this needs to be a 6, so we have 6 there. And there are no spaces in this whole complex. This last one, we have a very long cationic complex. So we have 4 waters, which their name in the naming system is aqua. And then this oxalate ion, which has its name of oxado, where aqua is going to come first. So we have the tetra aqua, and then this oxalato, which if you're more comfortable with that, you can put it in its own parentheses so you know where it starts and ends. And then your platinum. Then this, the oxidation state of the platinum, water contributes nothing. The C2O4 is a -2. The Br is a -1. There's 2 of them. That's -2. So we know that the platinum needs to be a 4. And then a space, and we have bromide.